Huzzah! Can you hear me? Captured as well. I think you can hear me. Awesome! Alright. Hello everybody. Hello internet. In this video we are going to be looking at building things. So we're doing a live stream. There's nobody here, obviously. But we're doing a live stream to pull together some more code for our World of Zero arcade. So this is going to be a game that we're hosting out on Beam. So I'm going to run it locally and then it's going to go out there. So I didn't really have time to record an actual video, so we're doing a stream. It'll probably be like an hour or so. Yeah. So if you can see behind me, kind of covering it up. So behind me there is a box. That is Data Cube. I've spent the past 3 hours and another 3 hours yesterday, which is why there was no video yesterday, because I thought I was going to get it done yesterday. I was trying to get that working so that we could actually tie everything together and pull it together. So yesterday I was trying to get Raspberry Pi, the Raspberry Pi in there to actually boot, which sounds like a simple problem, but it's not, apparently. Or I'm just really bad at it. So I was trying to not use Noobs, which is their package thing, and that was just totally breaking. So, what I've done is that's working now. We have the OS is running, and I have the actual application we need to run out there. And I can actually run ASP.NET things. The problem I'm running into now is we built the server for DataCube on... We built it with ASP.NET, but we built it with Visual Studio 2017, and they had changed everything. So it doesn't actually work. So I'm trying to figure out a way to get that whole thing to work without backdating everything, because I could go back and it would work, but that, I don't know. It's a mess. So when that gets working, I'm gonna do a video on how I pulled that whole thing together. I also spent a long time trying to figure out how to record that, and it totally failed. So I don't know how to record two PCs and sync them up in a way that doesn't just kill everything that's connected to it. So we're going to do this. I need to test out my streaming setup for Ludum Dare anyway. I'm getting new lights because these ones, I'm using like shop lights, and they're totally... They are way too hot. Which is part of the reason why my camera keeps overheating. Because even though it's about 65 degrees when I start this stream, by the end it'll be in the upper 70s. So, anyway. I'm talking way too much, so let's do this. I don't actually know what I want to make this into. I just really like this art style of shapes. So if you're not familiar, we did a video where we... pulled all of this stuff together. I've actually expanded it a little bit. So there's a way you can either close it or open it. So I'm thinking like you get shot and then the side pops off or something. But this is sort of where we're at right now. Super simple, it's just a shape. But I think it looks super sweet, especially with the animations. So we've got that. I don't know where to start. I don't really know what we're building. I don't know, it's just... Figured I'd hang out and do something, because otherwise I was just going to pull my hair out trying to get that Raspberry Pi to work. So, let's build something. We can make it move. That's easy. So let's make move you a bit. There we go. So let's make a player movement controller. And let's actually just throw a bunch of components out, and then we can implement them. This will kind of get us a little bit... I don't want to just kind of rush into this and just kind of... So a lot of my videos, I kind of show how to get things working. I don't necessarily show... I don't necessarily show the best way to do things, and that's on me a little bit, because part of this is there's just a time constraint, and I don't Doing things the right way usually takes a lot longer, and doing them the right way is dependent on what you're doing. So I kind of leave that up to you guys to figure out. So we're going to try to do it the right way here because I actually want to release this and be able to maintain it. So we're going to have a movement controller. We're going to have a character. We're not going to call it a character controller. We're going to call it a shape controller. And that is going to hold all of the information about our shape, I guess. What else do we need? We need movement. We need to hold all the information regarding our shape. I think we can leave it there for now. So this shape controller is just going to hold general information. It's not going to hold anything special or anything like that, but it's going to hold the number of sides you have, which is going to be sort of your health, as well as like your speed and all of that other information that you may need is going to be contained here. And then it's going to kind of be like the controller that handles everything. I say it handles everything, it's not going to handle everything. But we'll get to that when we get to it. So int sides. So a lot of this stuff is already stored somewhere else. Like the dynamic shape renderer already has the number of sides. We don't need to worry about storing that so much. We don't need to worry about persisting that so much, but we need to worry about something needs to control that. Something needs to say, this is how many sides you have. And I don't think coming from the view or what's rendering is where it should come from. So the shape controller is eventually going to pass that to our render. I think that's probably the best way to do it. Let's take this. We've got our sides. Let's give it a speed as well. So float speed and set it to 10. We'll have to figure out if that's good or not in a bit. But we have our shape render. That's good. That's fine. I'm gonna tie. So we have a choice to make. And that choice is, do we want our shape controller to connect to a bunch of objects and update them? Or do we want a bunch of objects to subscribe to our shape controller and then update based on that? And I think the best way to do this is to actually subscribe to the shape controller and update it that way. That way we don't have one thing that needs to know everything. Everything's kind of separated, and just if something needs the information, it can go and get it. I think that's the best way to do it. So let's take our shape controller and we're just going to plug it in here. So shape. That sounds awful, but we'll do it. And I think that means we can actually remove the number of points here. And then we have a bunch of references to that down here. So we can just do int points and set it equal to our shape dot sides. And this will this way we're sourcing those points from our shape instead of doing something else. So hopefully we can stop that. Add our shape controller. I'll move that to the top just so it's somewhat sensical, because that's going to be used all over the place. So this dynamic shape renderer now is getting its sides from our shape controller. So we should have 5. And as I change this one now, we should get more and more. And now I didn't put the limit on it, so it can go quite a bit higher. So, yay. I guess well, I probably just broke it because I went way below 3. May have just crashed Unity. We'll see what happens there. Yep, pretty sure. Pretty sure I killed it. Right. One sec. Oops. All right. So let's start this again and not do that. So I think that's an indication that we probably want that limit back on this, just so in the UI we don't screw things up. So I'll go from 3 to 32 again. And that's just going to prevent us from going to any crazy values. And it totally reset our scene because we crashed. So let me set this back up again. Pull in our shape, move it up, and then connect things. Yes. This should work now. We should get the exact same thing. I just can't break it by going below anymore. So that's good. Everything is as it should be, which isn't much. So we need to figure out what we're actually going to do with this. And I'm not sure exactly what I want to do. I was thinking like some sort of twin stick shooter thing. The problem with that is, since it's on a stream, it's going to be really hard to do twin stick shooters, especially on a PC. My concern there is, how do you point your mouse where you want to go if your mouse is going to be over a stream? I'm not sure that's going to work as well as I want. So, what we could do, so one of like my first games ever, I called Particle Field. It was made with Yo-Yo Game, the Game Maker, Game Maker 7, I think, and I think it was all done in their like graphical language. But anyway, that was like 8 years ago now, a long time ago. But what that was is effectively you were a particle, and there were a bunch of other types that would come across the screen and had different effects and would try to seek you out. So it's not the most complex of games, which is why I'm thinking it might be a good idea, because we can implement it, and we can implement it relatively quickly. We could probably get pretty far actually in this stream. But it's also, I thought it was fun. I made a few. I've come back to it a few times because I like the idea. It's more. It's effectively just a dodging game, but it just looks pretty. So yeah, let's start there, because a lot of the stuff is going to be the same regardless of how we do this. So I'm going to add a movement controller here, and we're going to start making this thing move. So let's pull in our shape controller, and we just want to grab that again, because our shape is going to actually control how this whole thing is moving. So we've got the start, don't care about that right now. That's going to give us our speed. The two other things I want are the float. Should we do a vector 2? Sure. Movement. And so this is just going to be like the X and Y direction. So if you have a thumbstick, you're going to give it some sort of vector to go along. And we just want to move our shape along that vector. So we're going to transform the position by that movement vector times the shape's speed times something else. The time delta. Why did it take me so long to think about that? And it doesn't like this because this is a vector 2. So we are going to actually change this to a vector 3. Which sounds silly because we're working in two-dimensional coordinates. But this is actually going to prevent us having to like instantiate a new a new vector 3, for example, which just to do this math, that seems silly, especially since then you're just allocating a bunch of memory you don't need to. So if I did this correctly, it should work. Let's actually tie in some of these values. So there's an X and a Y. I think those are the axes we're moving along. Actually, I think that's wrong. Hold on. We can find out really quickly. I know you don't compile, that's fine. So there's an X and not a Y, but a Z. So we're working on the X and the Z plane, and the Z is going to be up and down. So that's important because then we can just do input get axis of our horizontal. And this is just temporary. Obviously, this is not going to work with our networked solution, but it will work, hopefully, for what we're doing now. So that should just tie directly into the WASD keys. But I need to actually connect the shape controller, otherwise that's really not going to work. Cool. Yeah, so we can move our shape around. It actually kind of floats a little bit, and I think that's just Unity's input system that's causing that. But yeah, you can move it around, and it's relatively easy to control. I wouldn't say it's great. It feels very floaty. And on the side there is a lot of effects. Yeah. All right. So we're gonna ignore all of that because that is way overdone. I think I maxed that out. Yeah, chromatic aberration all the way up. Okay. So that's insane, but that's fine. So movement is working. That's all we needed to do. What I want to do actually is pull out, like I know we just set this up, but I actually don't want to do it that way. There's going to be a input. And so we're going to actually create an abstraction of our input types, our input behavior. And so this is going to allow AI and like normal input, so if you're just playing it locally, or networked input if we're playing this over Beam and we have some different clients. So we're going to do an abstract. Actually, let's just create an interface. That'll work. Input controller. So this is just going to be a interface that people are going to implement. That's going to define how they can control it. So there's going to be a float for the whoa, that's not how you spell that. Horizontal with a get and a float for the vertical. So I'm not exposing any setters here because the backend implementation is going to handle that. So the consumers don't need to be able to set. That doesn't make sense. They just need to be able to consume this stuff. So there's just a horizontal and a vertical, and that's all they need. So let's actually implement one of these. So we're just going to do a basic input controller. And so all this is going to do is grab that input controller. That's not right. Pressing all the wrong buttons. There we go. We'll implement those. And we're getting some private setters here so we can actually set those up. Thank you, ReSharper. Now, these are actually going to be auto properties, so we actually don't need to create any variables for them. If you look at what happens here, C#'s compiler will actually create one for you, and you don't need to worry about it. Unless we need to actually tie into this, we don't need to worry about it. So what I'm going to do is this bit right here that we had pulled out, I am going to plug it in here and stick our horizontal and our vertical onto this. And so we're now pulling in our horizontal and our vertical, setting them to that. And so we should, oops, this isn't right. I'm going all over the place and all of them are wrong. Okay. So instead, all our movement controller needs is an input method. So it's accepting input, so we just need to give it an input controller. And this will just be our input. And then instead of doing move input.getAccess, we're going to use our new input object and plug in the horizontal and the vertical from that. And so this should get us exactly the same thing. But now it's abstracted out, which is going to give us some really cool features. So if I want to do like an AI or something that actually uses this, it actually becomes really easy to work with this. There's compile errors all over the place. What? That's not a compile error. None of those are. Why is my input not showing up? What have I done? Don't tell me Unity doesn't expose interfaces, because that's going to be really unfortunate if it doesn't expose interfaces. I'm going to be quite annoyed. Yes? No? Maybe? No. All of the best intentions. I think Unity is really good at enforcing really bad programming practices. I think that's just like its thing, which I'm not really a fan of. There's just so much stuff that you're doing in Unity that you really shouldn't, like public fields, probably not a good idea, and apparently not using interfaces. So we're going to rename this as just an input controller. And that's going to be gross. So we're going to make this an abstract class, but we're also going to have to, can I make an abstract property? I don't think I can. This is going to be fun. We need to extend a mono behavior because you can't have multiple inheritance in C#, which is why interfaces are fantastic. So we're going to call this an abstract get. I don't actually know how to do abstract properties, so this is going to be weird because I have never had a need to do this. Not valid. Okay. We're going to guess in the dark until this works, or it's not going to work, and then I'm going to make something up. Cannot be private, so we'll make this protected. There we go. That makes sense. You can't have a private thing that is abstract. Then nobody could implement it. Okay. Everything makes sense. The world makes sense. This doesn't, though. There we go. Does not implement override. Cannot change access rights. Sorry, I'm going all over the place. This is not what I had intended. Protected set. I know it's never used, that's fine. Cannot specify accessibility modifiers for both accessors of the property. Well, we're gonna be here all night. I really, really wish interfaces worked. Yay! It works! Huzzah! Okay, so you can't actually specify you can't specify the accessors of both of these in here, because that you can change one of them. So this thing is public, and the get gets that public modifier. But then we can change the set to be protected. But if you do both of them, it doesn't really make any sense, because then you've got 3 access levels specified, and you only have 2 things, which doesn't actually make any sense. So that should cover this. And now this should work. And it's saying override. Oh, we don't need to do that because those aren't actually abstract implementations. That's a hard implementation. So this is an abstract class, so we can't instantiate it. But these are that's an actual thing. So this just automatically gets those. We don't need to specify them again. We'd be overriding them if we did, which we don't want. Okay. Sorry about that. Getting over a cough. Hopefully it's gone before the Ludum Dare. But we should have this working. I can now actually attach my basic input. Still really annoying. And we can move around. So we have exactly what we had when I started this. But now, if I want to, say, create something that just moves in a circle, so we're going to call it just a circle input. Actually, let's call it a bouncing input controller. So what this is going to do is this is going to track. Where's our basic input controller? I don't need it. That's fine. So this is going to track where we are in space, and if we exit the bounds, so horizontal bound, and a vertical bound, it will just bounce around. So we've got both of those. Those are our bounds. Public bool. Let's actually do a vector 2. No, we don't need to do that because we already have them stored. Never mind. That's silly. So when this starts, we are going to create a vector 3 random no help. No? Okay. Well, that didn't work. I don't know where IntelliSense went, but it's not here anymore. Let me try to get that back. Like, I can work without it, but it's really annoying when it just goes away like this. There have been so many weird things going on with Visual Studio that I don't really know what it's trying to do anymore. Come on. No? Maybe? Horizontal, oh, duh. Input controller. There we go. So now we're getting a little bit more help. So we can set this equal to a random value. So I'm just going to store this. Var random equals random. Let's do inside a unit circle. So this is going to get us some point inside of a unit circle, and we want this normalized. So we're going to get a normalized vector, which is going to be the initial direction we're going to go. And then we just need to assign that. So our horizontal is going to be equal to the random x, and our vertical will be equal to the random y. So effectively, we're just picking a direction going in there. When we cross one of the bounds, we're going to bounce off of it, and then we'll go somewhere else. So we have both of those. If horizontal is greater than 0, so this is just a quick bounds check. So if our horizontal is greater than 0, we are moving in the positive direction, which means we need to check if our current x dot x is greater than our horizontal bound. So if we've moved off of that, then we need to invert. Then horizontal times equals -1. And we just need 4 of these. So these two can be else ifs. So for the horizontal, you can do an else if here, but you can't do it for all 4 because you could go off the vertical and horizontal at the same time, which can get a little bit funky. So we want to see if it's going in the negative direction and if the transform position is less than the horizontal bound, the negative horizontal bound. And then just copy and paste. So let's plug in the vertical, and we should be able to just do this the same for these, as long as we use the vertical bound and we use the z, because we're working with x and z here. So this should move us and bounce us around, and theoretically it should work. And so the cool thing is since we have that abstraction layer of our general input controller, I should be able to just plop this in here, disable this, and attach this, and things should just start moving around. I didn't actually set these, so that would be handy. So now it is going to just sort of bounce around, and you can see as it goes outside of the bounds, it changes direction and just does sort of the Pong thing, I guess. So this is one of the cool things abstraction gives you. I've done this in the past. I really, really like abstracting things. I think it's really cool and it's really powerful. So if you do it well, it makes things really nice because you can kind of just pull parts out and put parts in. If you do it wrong, then everybody gets really confused and you have no idea what's happening anymore. But yeah, I think it's a really handy tool, no matter what you're working on. So there's tip of the day. All right, that's relatively useless though. We can probably turn this into like some sort of enemy or something that like bounces around the screen a few times and then does something. But that can wait. What else can we do? Let's actually create one more. I know I'm creating a lot of these, but let's do a seeker input controller. So when this spawns, it's actually going to target the player, and that's going to be its target vector. So we're going to give it a public string. How do we want to do this? We need some way to find our player. And there's a lot of ways to do that. So we can tag them as the player, and then we can find by the player. We can also just give it an object reference and use that. That's probably faster, I think. But this is a little bit more generic, though I think tags are not the best tool. They have a tendency to break a lot, just because you rename something and then everything's gone. So yeah, we're going to do this. So this is going to be our target tag. So it's going to find the first object it can with this tag, point at it, and go in that direction. So effectively, you'll just spawn one of these, and it will be like a targeting missile. But it'll only target it initially. So we can have two different kinds, one that targets like perpetually and kind of has like some sort of velocity, and one that just goes right at them. So there's a target tag here. That's not what I want. Game object dot find with tag. So we're just going to use this one. It's only going to get, so find game object with tag is only going to find the first object. I think the first. There's another one that will find every object in the scene with this same tag. Don't really care about that. We just need one. So this is going to be our target. And then we just need to derive the vector towards that. So that's the way you do that is the target minus the current position is going to give you a vector at your target. And then we just need to normalize that and assign it to our horizontal and our vertical axes, or inputs. So this is going to be our vector. Is it going to be our vector? Yes. So we're going to take our target minus target.transform.position minus our current position. And there's that. Then we just need to normalize this. So vector.normalize. So there's two ways to normalize. One is just the normalize parameter, which creates a new vector, I'm pretty sure, and returns it. This one is going to do an in-place modification of it, which seems really weird. I would have assumed these would be immutable types, but they're not. So, So anyway, getting sidetracked again. We need to take that vector now and assign it so our horizontal, we first need to do an input controller. There we go. So our horizontal is going to be equal to our vector.x, and our vertical is going to be equal to our vector.z. And before we normalize it, actually, just to, in case anything bad happens, I'm going to set this vector.y equal to 0. Because we're working on this plane, due to just some like image effects or specific 3D effects, I guess, we may actually not have everything flat on that plane. Some things may be higher or lower. So to get that plane nicely, we're going to actually just flatten it down to that plane first and then normalize it, which should work unless they're directly on top of one another, and then everything's broken anyway. So we don't need the update, so that should just go away. And I am going to need a second shape for this. So we have another shape, which we can just drop over that way. And I'm going to color this. I have another color. Green. It is apparently green. Or orange. We'll do orange. Orange sounds like a good color. I can drop these inputs, we don't need them. And then we're just going to plug in a seeker. And we're going to target a player and connect it there. And then I'm just going to slow this down. And we're only doing that so that it's just slower, I guess, so we can actually see things happen. And then that's tagged as our player. This is 2, that's not good. So let's untag that for now. And so we get this triangle targeting our player. The player is supposed to be bouncing right now, which is why they're freaking out. Whoops. Sorry about that. I just totally kicked it off into oblivion. There we go. So let's reset a few things, get back to our basic input. And so I'm going to now, we now have like these seeker things that just kind of target randomly, or they target the player rather. I'm going to shrink it just a tiny bit. And so we get these little triangles targeting our player, and then you just get to dodge them. Obviously, we can make it far more interesting, but you kind of get the idea at this point. So we can actually start this now, or start actually building this. So I'm going to create a level spawner. So ideally what I'd like, if we're doing this, I would like the chat on Beam or whatever, like various different interactions to be able to actually spawn things in this game. It'd be really cool to tie it into almost all sorts of different services. So like if you tweet about the game, whoever's playing it gets attacked by something. And it's just kind of like socially driven. I think that's a really cool concept. I don't know how well it would work, because obviously it depends on who's up and who's not. But I think it'd be cool. So we're going to try to design this with that in mind. Don't really know what that means yet. But for now, we're just going to make it spawn a bunch of those seeky majiggers and try to target the player and see what we get. I hate this cough. So, level spawner. That should work. For now, I'm just going to pretend like there's a single object it can spawn. This will change, but it makes things easier because we don't have to worry about like selection or anything. So we're going to create a spawn, and we're going to have a spawn timer. Float. And so usually when I create a timer, I have a time limit, which will be this spawn timer, and then I have a private timer in the background that's going to actually increment. So it just counts up. We lost IntelliSense again. That's great. So if our timer gets greater than our spawn timer, then we reset it and do some sort of tick event. So timer becomes 0, and then we do a tick. And I can't complete because everything is gone. Alright, so this tick is going to fire every timer tick, which is going to be however long the spawn timer is. So we are going to spawn it at some spawn points, which means we need to know where those are. I'm not going to actually pretend like I know where those are. So we're just going to create a transform array that's going to store the spawn points. And we're just going to choose a random one. So spawn point is going to be equal to the spawn points random range between 0 and our spawn points length. I've been using Java and they use size, and I think there's something uses count, but anyway, that should work. We should be good. I think we're good. So we have our spawn point, and we have what we need to spawn, so let's actually just create that. So instantiate a new spawn at our spawn point dot transform. Oops, we don't need that. Dot position. It's already a transform. We don't need to go any deeper. And we'll actually do quaternion identity. because we don't care about the rotation here. That something else is going to solve for that. So we aren't going to worry about it. Yeah. Okay. I just started that for no reason. My voice is getting very raspy. Sorry about that, but carrying on. We're going to call this guy the Seeker for now. And I'm going to remove him and tie him back in to the spawner. And we're just going to give a spawn timer of like 2 seconds. So we'll spawn one every 2 seconds, which is probably going to be super slow, but that's fine for now. And then we just need 4 or 5 of these. So I'm going to create them just in a square around the player. Sure. So -5 for that one, and -5 for this one. Sorry, I'm reaching around you guys there. And then we can drop those down there. And now we have, oops, that's not gonna work. We have 4 spawn points in each corner. And so, if I actually hook those up, because that's important, things should work a little bit better. So we've got those 4. We've got our Seeker and we've got our spawn timer. So I should be able to just kind of point things at it. Yeah. So it starts spawning them, and then you get to dodge them, I guess. Which, admittedly, it'd be cooler if they did more. But for an initial test, it works for us. So at least this gives us something that can spawn things, and we can at least play a little bit. So the idea is you'll dodge these things. Right now, you are super fast. So let me actually drop that down to less than half of that. Because there's no, so you have 200 milliseconds of lag, just because of the way their system works, the way Beam works. So we need to kind of design our systems a little bit around that, so the whole thing can be played with that kind of latency. Which, now that I'm thinking about that, let's see if we can simulate that. How would we do that? Coroutines? Can we do coroutines? Let's do coroutines. We have never done coroutines before. So how do we want to do this? Coroutine. Yeah. So is there a way to delay this? Coroutine. Maybe. Hold on. So a coroutine, traditionally, Unity has a little bit of a different idea of them. But traditionally, a coroutine is a function that picks up where you left off when you start it. So yield is a pretty classic example. It's actually used to implement these. But I am getting lost. How do we want to do this? So let's actually create a input controller that simulates input lag. So lagging basic input controller. So this is going to actually take whatever we have, execute, that's not what I want. We want to completely copy our basic input controller. Where did it go? There it is. So we're going to copy that. I need to also bring over the input controller here. And so all this is doing is just setting our vertical and horizontal. We need to delay that by a bit. Not sure how we're going to do that. I think we can do a queue. So what we're going to do is create a few gross things. So let's create a private class. We'll call it we'll just make it a struct. That should be, yeah. We'll call this our movement buffer. Sure, why not? That ought to work. And then we're going to create a public float horizontal and a float for our vertical movement. So the idea I'm thinking here is we're not going to do this here. Instead, we're going to create a new public movement buffer. No, we won't do it this way. There's a better way. So, don't need to do that. We need a queue of these movement buffers. So queues are first in, first out, which mean, first in, first out, which means the first thing you put in there is the first thing that's going to come off, which is great because that's how movement or input works. So we're going to input something and we're just going to wait until that first element in our queue is passed whenever the time is. So we're going to also store another float, time. And so this is actually going to come from Unity, that we're going to use the time.time, and that will actually pull out the time that event occurred. And then we can increment that and see when we get greater than that, we should fire. So movement buffer. Create a new queue for that. There we go. We can just create that right when we create our class, and we'll make it private. Cool. And so we want to take these input buffers and create a new class, or create a new buffer. So buffer equals new movement buffer. And we just sent our horizontal equal to that, and our vertical equal to this, like so. That's not how that works. There we go. And then I also need to pull in the time. So time is going to be equal to that time.time. And so now we have the time that it occurred, as well as the inputs. Then, if our movement buffer, I did not spell that right. There we go. Movement buffer dot peak. Why are you capitalizing yourself? ReSharper, you are getting very confused right now, and I'm not amused. So we're going to peek at this element, which is going to, there's three operations that queues really do. There is enqueue, which puts something into the queue. There's dequeue, which is going to pop something off of the queue and return it. And then there's peek, which is going to just return the first element in your queue. So the difference between a peek and a dequeue is a peek doesn't destroy your queue. It doesn't pull things off of it. Whereas dequeue is like a peek, but then also it pulls it off. So we want to peek at the time and say if this is greater, no, if that plus our delay is greater than time.time, Is that what we want? No, less than. Sorry. So we're going to take this time is going to be equal to our time plus time. Then we're going to add some sort of delay on top of that. And so when this value becomes whatever, so when more than the delay has elapsed, this time, the current time is going to exceed this sum. And then we should be able to have something pop off. And so when that happens, var movement is going to be equal to the movement buffer.dq. And then we want to set our horizontal, ooh, that's not right, equal to the movement.horizontal. And the vertical equal to the movement.vertical. So we don't have a delay here yet, so I'm gonna plug that in. But this should now, assuming it compiles, I may have misspelled some things because I don't actually know if this works. But assuming it does work, it doesn't. Oh, it might. Hold on. Ooh, maybe. We'll have to test this. It compiles, and that's a big step, but it doesn't mean it works. So the delay is measured in seconds, so 200 milliseconds is 0.2 seconds. So when I hit left, or when I hit right, we don't get anything. Operation is not valid due to the current state of the object. That's the problem. So if we never actually put anything into our queue. If the movement buffer dot count is greater than 0. So there has to be something in your queue to peek at it, otherwise it doesn't make any sense. And we need to movement buffer dot enqueue, the new buffer. There we go. So because of the way I wrote this, we probably don't need this check. I'm going to leave it in because I'm probably going to refactor this, and that's going to be a problem later. So what this is doing, we have two sections. This is creating an entry and enqueuing it in our queue. The next part is looking for an entry that has already occurred with the delay included in that delay or in that time. And then it sets that the current horizontal and vertical values equal to that. So effectively it's pulling out those delayed times. It's delaying everything by 0.2 seconds. Which you guys aren't going to be able to tell, but if I press now, there's a little delay. If I increase this to like 5 seconds, I can press the key and sit here for ages, and then it starts going. So it does work, and now I'm off the screen, obviously. So obviously, the amount of delay is going to really matter. But actually, it felt really good with 0.2. It didn't feel terrible. I say as it just goes way off the screen. Okay. Why is it being so slow? Stream offline. What? Did I lose things? Sorry, oh, nope. Apparently everything's good. YouTube was just deciding that it was time for me to be done, I guess? I don't know, I just closed the stream. But anyway, that works. We can actually do simulations of delay. And it does, even at 0.2, it does feel obvious. but you can actually a little bit more than this, and it might be a little bit unbearable, especially for like these kind of precision things. But I don't know how to fix that. And I make a lot of these like action-y style game things. So I'm not sure what's going on. But things are broke. But anyway, stream is acting up and I don't know what's going on, but it's distracting me and I don't like it. So, this is sort of where we're going. I don't know if this is where we're going to end. Yeah, I'm not entirely sure. But I think this is probably version 1. So we can create this, release this, get some people testing it and get some ideas coming. And then we can actually build a more advanced game than just this. This is sort of just the proof of concept to show, hey, you can stream a game and people can actually play it. So hopefully that works. And the cool thing with this is Beam has like arcade controls that I can actually overlay on the stream. And because of the simplicity of this game, we can actually do like a Beam plays the arcade, which I think will be cool. So if nobody is like, I want to play, then we can just have the entire stream take over and just play it. So yeah, I think it's going to be interesting. I don't know how this is going to work. I don't know what problems we're going to face once we actually start implementing this. I imagine there's going to be a ton of them, just because I don't know what I'm doing really. But yeah, I think it's cool. So I think we're in a good spot. I'm probably going to go to bed because I have to work in the morning. But yeah, that's probably it for now. So we have a bunch of stuff. This is going up on the GitHub page. There's a link in the description. It's on my World of Zero GitHub page. I try to post most of the projects out there, at least once they get closer to done. Some of the ones that are kind of like throwaways, I usually throw like a gist or a gist in the description for the video. But other than that, that's probably it for now. So if there's anything you guys want to see, this is a live stream obviously, but check out the other videos. Let me know in the comments or shoot me a message on Twitter or somewhere else. I don't know. I love hearing from you guys, and it really helps me figure out what to do. I try to put out a lot of videos, and it makes it a lot easier if I've got really interesting ideas that I'm really excited about. And you guys have really good ideas. So even if you think it's like a silly idea or you don't think you think it's hard or whatever, let me know, because those are the most fun. It's really interesting to take some problem that seems hard or seems something you don't know and try to solve it in an interesting way. So I'm sure we can come up with something. So yeah, if there's any ideas you have for this project specifically, I'd love to hear them, because I don't really know where I'm taking this. I'm kind of trying to build an interesting game that's fun to play and looks cool. Something that can be run for a long time without any issues. And also the games are short in this, which is going to be good, because there could potentially be a line and I don't want people waiting. So anyway, if there's ideas you have for this, preferably with some sort of like social interaction involved in it, whether that's like chat interaction or something, some way for people to get involved, yeah, I'd love to hear it. So I have rambled for far too long. I am going to shut the stream down, see if I can spend like 15 minutes trying to get that stupid Raspberry Pi to run ASP.NET. If I can't get it working, I'll see if anybody else comes up with any ideas. But if by like next week we don't have anything, I may just write it all in Spring, which is a Java ASP, and then we'll go from there, because Spring will work. I don't know if it supports serial ports, but we can figure that out. So that's pretty much where I am with that project. I was really hoping to get it working for Ludum Dare. I don't think that's going to happen anymore. Just because I've spent so much time trying to get this set up. If I can figure it out by tomorrow, it should be good. But other than that, I don't know. But yeah. Anyway, this is a stream, and I am wasting a lot of time because that's just what I do. I talk a lot. So yeah. Anything else? No. No, I think that's good. So yeah. Until next time. See you, Internet.